Okay, combinations. When we're talking combinations, order does not matter. Meaning, having A, B like this or B, A, we don't consider them two different arrangements. Okay, so it's considered the same outcome. So some examples when you want to apply combinations, right? So picking 6 numbers to win a lottery ticket. I don't know if you know 649. You know 649? You know why it's called 649? Because you pick 6 numbers out of 49. And if they select your winning numbers, you win, right? All right, so that's why lottery. So choosing, selecting members of a committee, okay? I would highlight that. Like, if you want combinations, if you're making committees, I mean, please don't think permutations, think combinations. Downloading apps on your phone, if you just want like a certain package of apps on your phone, we don't really care where they are at. If they're on your main screen or your second screen, it doesn't matter. If you have that app, you would say you have that package. A hand of cards, okay, is huge. Like if you have a hand of cards, we don't care how they're arranged in your hand. We just care that you have those cards, right? And so here's the formula for combination. I will also, I will say or, okay? We'll say or. This or that. So you're like, what's the matter? Like, what's up with this, right? So this is the most common, I would say, in most textbooks, so that you know it's combinations. But if you see just 2 numbers stacked like that, like if you ask Copilot to solve things for you, Copilot would most likely, or ChatGPT or any AI generated, they probably use this rather than this. So just so you know, okay? And how is this different? I'm going to ask you to recall NPR. What was the formula for NPR? Do you have that on your study sheet? It calls for n factorial divided by n minus r factorial. This is NPR, permutations. What is the difference between permutations and combinations in terms of the formula? What's new? You see that? You see the R? Right? Highlight that with a different color if you can. So the R, right? Order is not counted. I'm just going to say it that way. Order is not counted. Like having them arranged in a different order, we don't care about that. That's why we divide out R factorial, like R number of people we choose at a time or objects we choose at a time. So here's the side-by-side reason. So a permutation, like we're arranging, I will say this, arranging for picture, let's say. If you're arranged for a picture, we do care about, right? Like, I think you would all agree, like a picture where your friends are next to you or where you are on one side or the other side, it is a different picture. Okay, you would not say that it's the same picture. The order would matter. So if we have this, we would have A, B, C, let's say. We have Anna, Bernadette, and Clara standing like this. That would be one permutation, one arrangement. We could have these swapped, right? C, B. We could have Bernadette at the front, and then we have Anna and Clara like this. Or we could have Bernadette at first, and then Clara and Anna like that. By the way, how many ways can they line up without me doing this? Can we calculate that? 6? 6 factorial? How many people are there? 1, 2, 3. 3 times 2 times 1, right? That is 6 ways. We know that there's 6 different ways to arrange them. Okay? Or we go 3 pick 3 is 6, okay, no matter what. So we have 4 already, we need 2 more. We'll have Clara at the front now. We'll have Anna, Bernadette next. And we'll have Clara again up front. We'll have Bernadette and Anna like this. So there's your 6 outcomes. 6 unique arrangements. Okay. Combinations is different. A, B, C, like A, B, C is the same thing as A, C, B, is the same thing as B, A, C, is the same thing as all the other ones. In this case, we would go from the 3 people, choose 3. Let's use our formula. It would be n factorial. What's n? This is n, right? So 3 factorial over, it says r factorial. I'm using the formula, by the way. I'm going to have that on the screen here. N factorial, this is n. R is here, so r factorial, 3 factorial over n minus r factorial. So n minus r. Let's clean this up a little bit. What's 3 factorial? We can do that, right? 6. 3 factorial again, that's 6. And what's 3 minus 3? 0 factorial. Anybody remember what 0 factorial is? 1, yeah. We can cancel this out. If you cancel out, what's left up top here? It's not 0, guys, okay? If you cancel out, there's a 1 up top divided by 1. So it's just 3, choose 3 is 1. Example, Anna, Bernadette, and Clara want to create a group of 3 people. Answer, just one way to do that. We don't care about them arranging or standing side by side. We just care about how many groups of where those 3 are in can we create just one. Yeah.
What form of like the combination do you think is going to follow?
I can't tell you for sure. You have to be prepared for one or the other. I've seen this one, like I have seen this one more frequently. I actually cannot tell you when this has shown up, but I'm preparing you for it just in case. But it's so unique, you should maybe just have, like, you can have this formula like this, have the bracket in front like this, NR, which is equal to this, which is equal to that. You know what I mean? You can have them all like this if you want. Don't worry about it too much. Like you'll get the hang of it. You won't even be thinking about it too much in a bit. Okay? I use NCR mostly. So let's give this a try. Is there something else? Yeah.
Does it even matter though if it gets to the same answer? Or are they always different answers?
Right, so exactly, that's a good point. Will they ever ask you to use this formula to solve, to answer? No. They will only expect you to write like NCR, like there should be numbers here pertaining to the question. And as long as you come up with an answer, you're fine. Yeah, that's actually a good point. There are 12 hockey players. How many ways can a coach pick a right wing, a left wing, a center, a right defender, a left defender for her seating lineup. And before you panic, it's like, I don't know anything about hockey. Why do you make me do this? What's specific here is, add this to your notes, specific positions means that order matters. Okay, make sure this is nice and clearly visible to you when you review this. Order matters here. Therefore, permutation. Or FCP. What does FCP stand for? Fundamental counting principle. Like if you want to do the slots, you go for it. So we've got 12 players, so it's going to be 12 pick 1, 2, 3, 4, 5 positions, right? It's going to be 12 pick 5, or you just have one slot for each position. It's 12, 11, 10, 9, 8, okay? So this is 95,040 ways, okay, to make a team. Because Johnny being the right wing or Johnny being the left wing, it's a totally different team here because we're filling specific positions. So we're back to where we started. Nothing has changed, right? This is the same thing as principal, vice principal. If you notice specific positions mentioned, order matters, guys, okay? That's permutation. What about if the question just said, how many ways can 5 players be chosen for a lineup? Making teams or groups of 5. Order does not matter here. I will actually do the ODNM. Okay? Order doesn't matter quite often. So in this case, you can't do the slots, you can't do the fundamental counting principle. You have to go 12, choose 5. From the 12 we're just going to choose 5. Okay? So let's use our calculator for that. You have to use your calculator for this. You can use the formula. I would say maybe don't if you don't have to. 12, alpha window, and there's your combinations, right? Make sure you choose combination. Question, is the number going to be bigger or smaller than before? A lot smaller, because we don't care, right, in which order they are presented. We just care about any 5. Look at that, 792 teams. Okay, so make sure you highlight that the order doesn't matter. Therefore, I use combinations. So it's basically from the 12 players, choose 5. I know it's somewhat silly, but then it sticks, right? Okay, I'm not going to ask you to simplify by hand right now. I honestly am not going to do that. But hold on. We're going to create word problems. Okay, you need to be able to do this. You need to be able to create a scenario, make it simple, but just make sure it meets the criteria. So for example, 8 choose 5. If I ask you 8 choose 5, create a scenario that satisfies the conditions. That this means that there's 8, this is your total, and this is your groups of 5. That's what that number is saying. So we're just going to say there are 8 students in a class. Okay, let's just make it short and sweet. How many groups of 5 can be created? Done. You're done. Order doesn't matter. You're not going to mention any specific positions. You're good to go. What about 10 pick 3? This is your total. This is number of positions, or how many you're grabbing at a time. Okay? So you can say there are 10 students. How about this one? Running for president, vice president, and treasurer. How many ways can the positions be assigned? There you go. Here we have specific positions that we're mentioning, right? You can also say, how many ways can the first, the second, and third prize be awarded in a competition? That's fine with me. How many different ways can that be done? So you got to be able to do that. Okay. Next. Here's where we're going to actually apply this to scenarios, and I'm going to ask you to try that. It's giving me a headache, literally. I'm having a headache right now. So if I make a mistake, I blame it on the headache. Okay, 53. How many ways can you pick 3 different flavored ice cream scoops from 10 available flavors? Go ahead. What would you say, permutations or combinations? If you ever order ice cream, do you tell your server, I want you to first put the vanilla scoop, then I want you to put the chocolate and then the strawberry? You just give him your 3 flavors that you want, right? So order doesn't matter here. It's just any way, as long as you have those 3 flavors, we're happy. As long as they're different, right? They're all different. So like, I just want you to see it. If you've got chocolate, vanilla, and strawberry, is the same thing as, look at my art piece of work. My art is a piece of work, I guess I should say that. Let's say we have strawberry up here, we've got vanilla there, and chocolate there. It's the same thing. Order does not matter. I know someone in here is right now thinking, Mr. Dirksen, I'm the one that tells the server to give it to me in a certain order. That's okay, but technically it doesn't matter. So here it would just be 10, choose 3. That's 120 options. It's 120 options that you would have. We wouldn't care about the order. If the order mattered, it would be a whole lot more options that we could make. Okay? Given 5 juniors and 4 seniors, how many ways can a team of 4 be selected if there are no restrictions? What's our total here? Total is 5 and 4, right? So I need you to understand that you need to be comfortable with total, and you also need to be comfortable with distinct smaller groups that appear within the problem. If there are no restrictions, if I don't care what kind of mix I have, I'm just going to go 9, choose teams of what? Teams of 4, correct? So 9, choose 4. That would be it. I take the 9 people that are available, and I'm going to make groups of 4. Mr. Dirksen, how did you know this is combinations? How did you know that? What gave it away? This word right here. I just want teams, okay? I don't care about the order. I just want teams. So 9 choose 4 is 126 teams. Now it gets more specific. How many teams can you create if you need exactly 2 juniors? How would we do this one? This is how I have to go. 2 juniors. And how many more do I need to make my team of 4? So it doesn't say, but it's 2 juniors and 2 seniors, correct? Actually, it's and, so it's multiplying. So if I want 2 juniors, what would I do? I would go from the 5, I choose 2, and how many seniors are there? 4. From the 4, I will choose 2 as well. Let's calculate that. You grab your calculator. I still have that from before. So I'm just going to go 5, choose 2. That's 10. I'm going to go 10 times 4, choose 2. So I just go up, change the 4, right? And that's 6. So there's 60 teams. Does it make sense that my answer is smaller than before? Yes, you've put a restriction on there now, right? 126 is your universal. 60 is if you put restrictions on it. Can I draw your attention to something else that I want you to check all the time? What do these 2 numbers add up to? This is like how many juniors and seniors? So that is 9, right? That's my total. And what do these 2 numbers add up to? Sorry, it's going to get a little messy here. These add up to 2 and 2 is 4. So there's always 9 in total. And what's the size of my team? 4, right? So that's something you should be checking. Is my total adding up? And is the team still always out of 4? Because that was a restriction way at the beginning that we need to fulfill. Yes?
So you chose 2 juniors, but how did you know you needed to choose 2 seniors?
Because I told you I need a group of 4. Right? So if I say, hey, no matter what, there's a group of 4. If I say I want 1 senior, what are we automatically going to assume? That the rest are juniors, right? So that's a good question, actually. So what about this one? Exactly 3 seniors on the team. 3 seniors, let's write it out. And what does that tell us? 3 seniors and 1 junior. We got to fill. We got to still make our team of 4. Team of 4. Remember that. Let's go back up here, if you wouldn't mind. Team of 4. Right? That's why we do that. So this would be 3 seniors. Let's not mix it up. So we've got 4 seniors, and we're going to choose 3 from the 4. And then we need a junior yet, right? So from the 5 juniors, we're going to choose one. This is 4 times 5, which is 20. Okay, I'm going to ask you to I'm going to skip a few pages because you're not ready for some of the stuff that is in between. I'm going to ask you to just do page 62. There's a mix. There's a mix there. Page 62 for now. Okay? So page 62. Leave everything else you see on these pages for now. We will continue tomorrow.